Hi there, folks. Day 5 already. I'm wearing my NASA shirt. Yes, I'm wearing my NASA shirt in the hopes that today will go smoother, that I will fly through the solution. Because yesterday was a bit of a difficult day for me. I see that we all still have 1.5 minutes to go. So maybe let's take a look at what my colleagues have been doing. We do a little bit of friendly competition. My employers. And it's always fun to see how different or how people solve the problem differently. And this year we have some exotic choices actually. Mini Zinc, I had not heard of it, but it looks like some kind of constraint solving language. And one of my colleagues is solving, or at least for the first couple of days, he's solving them in Mini Zinc. And it looks really cool. It reminds me a bit of Prolog or constraint programming in. It's Chinese for me. I see like logical operators, but the fact that you can solve day 4 in what is this? Something like 30 lines of code. It's actually quite readable, even for someone that doesn't understand a word of the programming language. I'm intrigued. And other than that, Python is a really popular language as well. I have not written a single line of Python in my life, so maybe that's also something to take a look at. But for this year, let's stick with a tried and tested F#, shall we? Right on time for the puzzle. Let's take a quick look. Hydrothermal venture. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. This reminds me of a video game I played called Subnautica. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents. Your puzzle input. So we have lines. And every line of a vent is given as a line segment in the format. Okay, so every line represents a line between 2 points. Cool. The line segments include the points at both ends. In other words, yes, that makes sense. For now, only consider horizontal and vertical lines. That is a big simplification. Okay, so the horizontal and vertical lines from the above list would produce the following diagram. What does the 1 mean? What does the 2 mean? In this diagram, the top left corner is the origin and the bottom right is 9, 9. Yep. Each position is shown as the number of lines which covered that point. Okay, so that's the number of lines. Cool. Top left pair of 1s, for example, comes from that line that goes through there. Cool. The very bottom row is formed by the overlapping lines. Yes, okay. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. Okay, so we need to plot all the lines and see where we have overlaps, and every point in the grid where we have an overlap, we just have to count those. And before we do stuff that is too crazy, part 1 only asks us to consider horizontal and vertical lines. Cool. Doesn't sound too bad. Well, that's a lot of input. Yeah, let's not even think about the non-horizontal, non-vertical cases, because that would be math. We'll cross that bridge when we get there. So first, as a warm-up, let's parse this thing. Yeah, I always like separating my parsing from my actual behavior, so let's do that as well. Yeah, it's not, if you're doing speed coding or want to solve these problems as fast as possible, that's not the best approach because it's a waste of time basically, but I like the extra clarity it brings. Yeah, let's declare a type, line. Mm, and yeah, that's 2 points. Or the definition of the line is 2 points. And a point is, should we make that a record type or just an alias for tuple? XY, yeah, XY is common enough to just say that it's a tuple of 2 numbers. How big do the numbers get? Sub 1000? Sub 1000, looks like it, right? Yeah, that's good. So this will be our type definition. We have points, we have lines, and let's parse. Do we have an example? We have a small set. Cool. Let's grab that as well. That looks correct. Yep. Okay. How do we parse this thing? We need to parse every line. Which is actually also the concept we're parsing. So just call it parse line. Yeah, let's just split on that arrow thing. That's a string. Let's help out the compiler a bit. Let's split on that arrow thingy. That should work, I guess. I'm not, wait, maybe let's not, oh yeah, we do have a, I was thinking maybe let's do this in the REPL first, but let's see if this works. No. Arrays are not lists, that is true. Let's use the array syntax instead. Yep. It's again the warning that this deconstruction could fail, but we know it won't. That looks correct as well. Let's parse into x and y coordinates now. Ash is going to write a little helper function. Let's call it parse point. Split on the comma. No decimals, no decimals. That's let's call it x and y. Where's the closing bracket again? Where is the closing bracket? There we go. And let's just return a point. So it's a tuple of x and y. I'm gonna explicitly encode this as a point in the type system or in the type signature, so the rest of the code works with our types and not with native types. That's not the level where we want to return a point. This is the level where we want to return a point. Here we want a line, eventually. So this parses the point. What is... Oh yeah, we need to parse the strings to integers. Okay, so that's the parser for 1 point. And then we just do a constructor for parse p1 and then for p2 the same thing. That should actually work if I use the correct delimiter at least. Yeah, okay, I think this will work. A line from 09 to 59, a new line from 80 to 08. Yeah, okay, that works. So that's the parse. Next step is just for part 1 probably, the filtering. So whenever we have 2 equal x coordinates or 2 equal y coordinates, that's the only set of lines we need to take into account. What do we call that? Horizontal and vertical. Are those the 2 cardinal directions? Is that a term people use? I'm going to use cardinal direct or lines in cardinal directions, something like that. That's a filter, so still in the array world, why not? So let's write this function. What will this look like? We take a look at the we'll take a look at the organs of this object, right? So I'm just going to destructure it into the parameter value. You can destructure in there, so you can do something like this: x1, i1, y1, and you have a point 2, which is x2, y2. And if x1 equals x2 or i1 equals y2, then we have a cardinal line. So this should, yeah, this should be it, I think. How many lines do we have? Let's do a quick count. I'm taking really baby steps right now because yesterday I didn't, and it came back to bite me. So we have 10 lines. And filtered we have a problem. Sorry? Int does not match a type. Why? I don't see. Okay, it was the. No, let's try that again. I don't know why it's failing. Okay, it's not failing. Yeah, it filters something at least. Yeah, looks correct. So these are the cardinal lines we need to take into account for part 1. Now, how should we actually go about solving the puzzle? Should we generate every point that is covered by a line? Yeah, we need to count the number of points. I think it's going to be easiest if for every line we have, we generate every point on that line. It works because we have a discrete universe. And then we just... yeah, then we can just group by the location or something like that. Which allows us to count the number of lines overlapping on that single location. So let's generate a point for, or let's like let's make a point for every point on the line. I have no idea how to call this. Pointify. I like the term pointify, so let's go with that. Or maybe yeah, no, I'm gonna stick with pointify. Come on. So pointify will generate a point or convert the line to all the points. So it's a list of something or a collection of something. I'm thinking we know for part 1 that they're always on a single line or column or like vertical plane. Can we make it easier than what I'm trying to do already in my head? I don't know. I'm gonna also do this destructuring because we need the XY coordinates. Does it work if we just grab the smallest x1 and loop over until the biggest x2 thing? Probably the order matters. Let's play around with comprehensions a bit. So for x in 0 to 10, give me x. That should give me a list of 0 to 10. Yeah. What happens if the 0 becomes the 10? If it's the other way around, I think I'll get an empty list. Yeah. We could like do a reverse with this kind of syntax, if I don't misremember. But then we need to know, so I think we'll just like sort the x coordinates, sort the y coordinates. I need to see this visually. Let's grab something. I like have a super fancy setup with a tablet here. Let's see if it works. Oh, we're alive. Let's make that a bit bigger. Actually, I have no idea how to work with Miro or with this tool. How do you not select stuff? How do you scroll? Where's the hand tool? Is it like a shift? No. Aha, move around the board with the right mouse button. It's funny that it like figures out that I'm struggling and it gives me a nice pop-up. The UX of Miro is through the roof. So what I'm currently fighting with is if we have like a line like this, say this is the origin point and our axis go this way. Does it always work to take the smallest x and go from there to the biggest x? I think it does. What happens if they are on a vertical line? It's maybe also a case to take a look at, or a horizontal line. It's only for part 1 these two, so let's forget what I'm doing here. Let's take a look at this. So if we say from x to x, that's a single value that will work. Yeah, that'll actually work. Part 2 will need some basic maths probably, but for part 1 we can just loop over x, y, take the smallest one. So let's grab the smallest one. Min x? Yeah, let's call it min x. It's the minimum of x1 and x2. And min y is exactly the same. We also need the other one, right? Not just the minimum. Let's just do a sort then. And let's call it min max. And that's for the y's. Is a sort what I want, or is it a sort in the other direction? Sort is from little to big, right? Probably. Cool. And then we can just do the for comprehension thing I was thinking about. So for x in minus x up until max x. Is it the arrow or the do? I think it's the do. And then for the y in the same. There we yield the point x, y. The red squiggly lines, did not expect them. What's happening? Expecting a, oh yeah, it's list, list, and sequence, sequence. So if I destructure with list syntax, it needs a list. Okay. Probably this is it. Okay, that formatting took a while. Oh, let's play a bit with this because I'm not 100% sure. So pointify. Let's give it a. What's a horizontal line? Then y stays the same, right? So let's make it from, I don't know, 12 on 5th, and p2 is 14 on line 5 as well. What does this give us? 12, 13, 14, that looks correct. Let's do this in the other direction to make sure that works. Yes, okay. I'm gonna grab this and plump it into a test real quick. Because why not? So let's take a look at that again. Oh, no, that would be a bit too much. 14 to 17 should give us a manageable list. Yes, it does. 14, 15, 16, 17, that looks correct. Let's do one in the other direction. So 17 stays the same. 17 stays the same. I don't know why I picked 17. That's a weird number to see. So from 2 to 5. Yep, that should give us something. 2, 3, 4, 5. That looks correct as well. Cool. There we go. Yep, everything works as expected. So now we map the lines to their points. I think we're there. If we now just say like, okay, instead of having a list per line in here, let's flatten everything. So instead of a map, we can do a collect, I think. Does the same thing, but every list that is returned, it smooshes every list into a single list. And it's not working. Interesting. Because I am starting to use lists instead of arrays. Cool. So this should be a big list of all the points from all the lines. And let's group them by or count by. Can I do count by? Yep. And I want to count by the points themselves. So that's the identity function. This should give us for every point the number of or the number of occurrences of every point in that huge list. And then we just need to filter out the points. Oh, that's my very beautiful drawing, but I was looking at this. What do we need again? The number of points. Okay, so let's filter out the points with overlap. Let's filter again. The things we're filtering are the points and the number of occurrences. So the number of occurrences should be bigger than 1. Those are the overlaps. Good work. Let's see what we get. 2, 2, 2, 2 looks correct. And let's just count those. With a length, That is 5. 5 is okay for the example. Cool. Let's quickly run this on our inputs. I'm wrapping everything in a function again. So we do the parsing, we filter the lines, we generate the points, calculate the overlaps, and return the length, but we have to do it on the input, not on the example. This should still give us 5, yeah. Let's put that maybe in the test. Yesterday I skimped on tests. It actually didn't help writing tests. The problem was a mental bug, not a code bug, but solve 5 is not what I want to see here. Solve example. I'm gonna be writing a bit more tests for the harder solutions, or the harder problems. Okay, that looks correct. That took a while already. Maybe let's time this. How long are we? Come on. How long are we actually solving for part 1 already? It feels a lot slower than what I'm seeing here. It's saying it's only 500 milliseconds, which isn't fast, but it feels a lot slower. Okay, but we had this number. Let's see if it's correct. Hey, there we go. On to part 2. What could part 2 be? Of course, diagonal lines. And there are diagonal lines at exactly 45 degrees. Yeah, in a discrete universe that might help. So, okay, so we don't have to filter anymore, and we have to generate points for diagonal lines as well. You still need to determine the number of points. It should be 12 for the example. That sounds very doable, actually. It's still weekend. Why is this puzzle easier? The old copy-paste, so we don't have to support both cases with the same hacky code. Let's open up that file instead. Diagonal line. So what will change? Big thing that changes. We don't have to filter. So actually, the concept of cardinal lines is not necessary anymore. Pointify still needs to happen. Why is the syntax highlight? Okay, there we go. Pointify still needs to happen, yes, but I think we have a missing case for the pointify, which is the diagonals. Let's just do this with a test first. I thought I wrote a test for solve. Where did you go? That's really confusing. I copy pasted this file, but it seems different. Just for my sanity, let's do that again. Okay, maybe I didn't save the file, something like that, probably. So yeah, let's take a deeper look at pointify. Let's grab one of these cases, plug them here, and start playing for the diagonal thing. So the example was 1 2 1 2 2, no 1 1 3 3. That's an easy case. That should give us a head start. 3 3. So that should generate us 1 1 2 2 3 3. Yes, and right now it's going loco. How do we do this? We could detect the cases. Like up until now, we can do the cardinal check in here. It will work because the diagonal lines always have 45 degrees. Yeah, let's not make it more complicated than that. If we have a cardinal line, we can do the old thing, and otherwise we do something new. So let's make a name for this whole thing. I think you can use the as syntax when you destructure to have like a... Yeah, so you have a name for the whole thing. You could do the other way around, call this thing a line and do a destructuring in the function, but both work. So if this thing is cardinal, then we can do this thing. One more, yep. And otherwise we can do the new thing, which is the 45 degrees. Let's take a look at my beautiful drawing. Can we do the same thing? Figure out the minimum, the maximum? I think so. And then instead of doing a 1, 1, 1, 1, we can increment x and y at the same time. Yeah, we can increment at the same time for lines of 45 degrees. That'll work, I think. Yeah, probably. So I think we can actually also use this. Yeah, I think we can do. So let's put this above the if or the conditional thing, and let's do a different kind of generator here. So instead of stepping through both x and y's, let's just step through just the x's. Will that work? I don't. Come on, brain, help me out here. We need to increment both x and y at the same time instead of for loops, but we need to start. Back to the drawing board. So if we sort on X and Y, means we always will navigate a line like this. If we sort X and Y here, what would be the smallest X? This would be the smallest X. This would be the smallest Y. We can increase by 1. We just have to increase by 1. We have to loop over the x's and y's, or at least over the length of x's and y's, and have to increase by 1. Right? This is actually what we're doing. But how far do we need to go? For 45 degrees, I think we can just take a look at one axis, like x. Yeah, I think the original idea still stands. So it's x. I think for x this still stands, but for y we need to do like y plus 1 for the amount of yeah, I think maybe it needs to be something like this. Plus something plus something, and the something is like an index going from 0 to the length of our diagonal section. So let's calculate the length. It should be max minus min. Get a positive number. And then for x in 0 to length, let's not call that x, let's call that offset, something like that. And then we can do this. I think. Sorry, what is the problem here? Oh, it's min x and min y. That probably works. I don't know if there's like a general case where you can do this without any knowledge or without having to check for the cardinal direction at least. Interesting challenge, but not for today's puzzle, I guess. Let's see if this pointify thing works as expected now. 1, 1, 2, 2, 3, 3. Yeah, cool. Let's pointify that forever. I don't know what's happening here. Okay. Let's grab the expected output or the actual output, which we verified by looking at it. So I'll allow this. I'll allow this. Yeah, it works. Let's do the other case as well. There was a bit more tricky case. 9 to 7, 7 to 9. That looks indeed a bit trickier. 9, 7, 2, 7, 9. So it's giving 7, 7, 8, 8, 9, 9. Oh no, yeah, of course. There goes the assumption. What's wrong? What's going wrong here? Let's draw this out. 9, 7, 7, 9. Let's get rid of everything. 9, 7, 7, 9. What's happening? So this is x. This is y. 9, 7, 9 across here, 7 across there, and then 7 across here, 9 across there. It's a line like this, right? My 7, 7, 9. Right. Right. Right now we're doing grab me the minimum. Oh, grab me the length, which is correct. It's 2. And we are generating on that assumption. Yes, we are. So 1, 2 steps. But what are we doing incorrectly? Then we just say there is an offset. Minimum x will be 7, minimum y will be 7. That is actually not correct. Or it is correct, but it's not the way to generate all points on this line. How would I do this manually? Manually, I would just grab the point. Let's say we grab this point. So not the minimum x, minimum y, but just a point, and do a stepwise +1 +1, +1 +1, +1 +1, +1 +1, +1 +1. I'm saying plus, but actually it's plus in the x direction, minus in the y direction. But for blind to go like this, it is plus plus. So how do we do this? I love it when basic level math fries my brain to the point that I'm totally stuck. Yeah, but okay. Let's take 1 point as a general strategy. Just the first point, don't care. Then figure out whether we have to go up for the x coordinate or down, and figure out whether we have to go up for the y coordinate or go down. And then actually just do that. That sounds like a reasonable approach to do it without a PhD in geometry. Cool, let's try that. So we take a point, we figure out x and y directions we need to grow in, and just take steps towards that direction. So I think length is still a valid thing, but instead of doing plus offset, we need to sometimes do minus, depending on the direction we want to go in. And it's not min x, min y, it is literally x. Let's take the first point, yeah, x1 and y1. +1 +1 +2 +2 +3. Yeah, this will work. But the only thing that is not correct right now, I think, is this plus. So let's figure out the x direction and the y direction. How? We're just gonna encode like go back with a -1 and go forward with a +1, and then you can do something like offset times x direction, something like that. That will line up nicely. So if it's a -1, we subtract the offset, and otherwise we add the offset. Yeah. Okay, smaller subproblem. How to figure out the direction. If x1 is smaller than x2, that means we need to grow. So our direction should be positive, otherwise we should shrink. And for y, I think we can do the same. So if y increases, we're going down. Yeah, this will be okay. Let's see what we get for the original cases first. Did we break it? This value is not a function. Okay. Okay, let's do them like this then. There's one test still failing. Oh yeah, it's the edge case. So it's saying 978879. Yes, that looks correct. Let's do a quick triple check. Yeah, that's correct. So let's plug it in, make sure it keeps working, but I think we're done. Optimist me thinks we're done. So let's solve the example again. No. I didn't think 5 was the correct number. It should be 12. Why? Oh, how is this filter cardinal still in here? Is it because I copy pasted? Let's see. That's what was wrong. Lines, not input. The auto formatting, it confused me. Okay, so this should be 12 now. It is 12 now. Let's plug that in. And let's do it for the input and hope our CPU does not burn. We are reaching burning territory. It's not too bad. Hey, first time right. Cool. The geometry part was rough on me, but we did it. We did it, people. Yeah, feeling more confident again. Yesterday was a bit of a dent in the old confidence. Today we're back again. Let's take a quick look at what we did. What did we do? We just parsed the lines into points and lines because I like playing with explicit types a bit better. The cardinal thing for part 1. We used a strategy or an algorithm that made points for every point on the line, and then we just counted the number of points in that entire set that had like multiple hits to see how many overlaps we have. And that's it. Part 2 was a bit more difficult when generating those points because maths. Basically, it wasn't that much more difficult, but yeah, I suck at like on the fly maths. I need some time to look up things most of the time. But yeah, finished it. I'm happy. I wish you a fine rest of the weekend if it's still weekend for you. And I'll see you tomorrow for day 6. Bye bye.